Okay, let's do an example of this. So I've got this function here, just a little thumbnail. It's going to look something like that. So we want to know what its standard deviation and variance is. We're going to work out the variance, of course, first. We're going to use our formula, and we're going to find our mean, and then we'll find our expected x squared once I've found that. So finding our mean, remember going from our upper limit to a lower limit of x lots of our function. So I might just neaten that up a little bit first. So x minus, and then I've got x squared over 2 dx. So when I put this through my integral, I'm going to get x squared over 2 minus, that's going to become x to the 3 over 3, but I've already got a 2 there, over 6, so between 2 and 0. Substituting our 2 in, I'm going to get 2, 4 over 2 minus 8 over 6 minus, and all that lot's going to be 0. 0 over 0. So that's going to be 2 minus, let's make that 4/3. So that's 6/3 minus 4/3 is going to equal 2/3. So our mean is 2/3. That looks roughly right. That's 2, that's 0. So I expect to be on that side. Now just get a second piece of paper, and we'll do our expected of x squared. And as I mentioned the other day, I might just put this over the side, you'll see it. When I'm doing the expected of x squared, I want to do the same as I did with the mean, except I want to times it by x squared here. So again, I'm going to do a little bit of pre-work here, making this a little bit neater. So that's going to be x squared minus x cubed over 2 dx. Now I do my integrations. That's going to increase the power to 3 over the new power, which is 3, increase the power to 4 over the new power. In this case, I've already got a 2 there, so 4 times 2 is going to be 8. Between 2 and 0. Again, sub my numbers in. I'm going to have 8 over 3 minus, now 4x to the 4 is 16. And again, these are going to be 0. Ignore that. So that now is 2. So I've got 8 over 3 minus 2. Let's make them all over 3. Minus 2 is going to be 6 over 3. So 2/3. And so now I want my variance. Well, the variance, if we remember back to our formula, is the expected minus the mean squared. So it's going to be 2/3 minus 2/3 squared. So that's going to be putting it in ninths. It's going to be the times the top and bottom by 3 is 6/9 minus, and that's going to be 4/9. So that's going to be 2/9. And our standard deviation is going to be the square root of that. If you really want, you can write that square root of 2 over square root of 9, which is